we've got a lot to go over here with the cat skull, so. What I've got is a complete skull with some parts missing because these have been beaten up by the students. And then a sagittal section of a skull so we can see some of the internal structures and try to make sense of the relationships. But start out with the easy stuff, actually the stuff that Nick's worried about because this is going to be in 2 exams for him in a couple of weeks. The lower jaw has only one bone in mammals, and that's the dentary, also called the mandible. So we can see that here. We can see these 2 holes right here. In us, we only have 1 pair of holes. And of course you have a chin. That's actually kind of a unique thing that humans have. Other primates don't have a chin. And the classic statue of the thinker, we're thinking like this, so your fingers are resting on your chin, called the mental protuberance, and your index finger and thumb are on the 2 holes, called mental foramen. And that's why they call that, because it's a classic statue of the thinker. It's got nothing to do with these being involved in thinking. It's just named after a statue. Kind of silly, but that's what we see there. Then we've got these points of articulation. So here we see where the lower jaw is articulating with the squamosal bone. In us, because our squamosal bone actually fused with the mastoid to make the squamosal, to make the temporal bone, we call it the temporal mandibular joint. Some of you know as TMJ, especially those of you who wore braces. So here it is, this articulating point going with the squamosal. If we look at it, it's flared like the condyles we saw last week. So it's called the condyloid, condyle-like process. Also called mandibular condyle, so we know, oh yeah, it's the mandible. Because true condyles are found only on long bones. And this isn't a long bone, but it looks like a condyle, it acts like a condyle, so condyloid. This process here is called coronoid. Coronoid means wave-like. Do you notice it's a lot thinner? Because this isn't to articulate with bone, this is for muscle attachment. If you put your hand on the side of your head above your ear and you clench your jaw, that muscle is your temporalis muscle. And it attaches here to the condyloid, causing you to close your jaw. So that's why it looks different. It's not for bone, it's for muscle attachment. So lower jaw done. Let's take a look here at the top. Oops. Of course, nose, eye socket, right? Giant kitty brain that it uses to remember it's your God and master. So these 2 bones on the bridge of the nose, nasal bones. That's not too bad. But most of your nose, the sides of your nose, the sides of our kitty cat's nose, is actually made up of a different bone. And that bone holds the canine and premolars and the little molar down here. That is the maxilla. Unlike you, kitty has another bone holding the incisors, called the premaxilla, just like we saw with the mud puppy, right? All right, now let's get to inside the nose here, deep into the nose, and we'll notice there's some bones in here. First of all, you see all these little scroll-like pieces of bone? Those are the turbinates. They increase surface area so you can warm air coming in. For an endotherm, that's really important. There's a little bone right here called the vomer. Now let's see if I can show it to you with this one. No luck. Should have known. Let's see. Who has sagittal section with that? Cut open skull. You do? Okay, I'll be right back. So, should have done a better job of looking to see if you had that. Yeah, all right. Oh, that'll work. Thank you. Thanks. So this is only a partial one, but your nasal cavity is divided up into a right and left-hand portion. Oops. A right and left-hand portion. That gives more surface area to warm, moisten, filter air coming in. There's our turbinates, our vomers here, and it's coming up to meet this structure here, which is the ethmoid. This in particular is called a perpendicular plate of the ethmoid. On top of the ethmoid, we have all these little holes. These little holes are so olfactory receptor cells can carry information to the brain. So these holes are called olfactory foramen. And when you see a structure with a lot of holes in it, kind of like a shower head, it's called cribriform. So this is called the cribriform plate of the ethmoid. All right, back to the outside. Let's go to the easy stuff again. So premaxilla, maxilla, nasal, not too bad. Here's kitty's forehead. Unlike you, it has 2 bones making up the forehead. called frontal bones. On the side, parietal. See this bone here? It looks like a scale. What type of epithelial cells are flat and scale-like? Squamous. Squamous means scale-like. Good. So this is the squamosal bone. Coming back here, we've got linear elevations. Running right along the midline is the sagittal crest. Running on the back of the skull is the lambdoidal crest. Where they meet, supposedly looks like the Greek symbol lambda. So that's called lambda, that intersection. But we can see along here other bones as well. So right here we have between the right and left parietal on either side of the sagittal crest, interparietals. Here we're on top of the occipital bone. These are supraoccipitals. So they help to make the lambdoidal crest or lambdoidal ridge. This part here is on the outside. When you feel the back of your head, that bump back there is the same region. That's the ex-occipital. And then down here at the base of the skull, we have our basi-occipital. All right, so our ex-occipital has a big hole in it. You all know its name, foramen magnum, and articulating structures on either side called occipital condyles. So you already know all that. All right. Then there's something weird here. We got these big bubbles. Looks like the cat skull's been playing with poison ivy. But those are tympanic bulla. And that gives them a resonance chamber. It's one reason why cats have a more sensitive sense of hearing than you do. We lost that because if you think about where your foramen magnum is, if it was back here, you'd be walking on all fours. To walk upright, the foramen magnum had to move down here. And that meant that these would be in the way and shrank. That's why the human skull doesn't show that. All right, so these are the tympanic bulla. They're involved in processing auditory information. This hole here, external auditory canal. All right, we have a little bone back here. Oh, this one's broken. A little bone back here on the tympanic bulla that looks almost like a V. This is the mastoid. That little bump right there, if you put your hand behind your ear, right about where some of your straps are right now, there's a bump back there. That's your mastoid process. In humans, the mastoid and squamosal fuse to give you one bone, called the temporal. But in kitty cats and other mammals, they're separate. So mastoid with the mastoid process and squamosal. Now, the squamosal sends an extension of bone forward called the zygomatic process. And another bone here called the malar sends an extension of bone posteriorly, also called zygomatic process. The two meet to give us the zygomatic arch, your cheekbones. So if on the day of the exam I put a tag here and say, name this bone, malar. If I say, name this process, zygomatic process. All right, of course, here's the eye socket. So we have these projections behind the eye socket, so post-orbital processes, inferior and superior. Getting into the